Hello, this is Caleb Arend. This is the blog post for JavaScript 311 class 12. And today we're going to be going over a few questions here, and I will share my screen so you can see those. We're going to go over what is the difference between operational and programmer errors. What is event-driven programming? What are worker processes? Describe how Node.js can be made more scalable, and explain global installation of dependencies, and explain RESTful web service. So let's dive right into those. And the first one, which is probably one of the easiest ones, is what is the difference between operational and programmer error in Node.js? We have a blog post by Calvin Puram, and he describes the difference and defines them too. Operational errors, these are runtime problems experienced by correctly written programs. And so those can be errors such as a failure to connect to database, invalid input from the user, failure to resolve host name. Really like the invalid input from the user. That could be a big one of why your code's not working with what they're giving you. But then programmer errors, these are bugs. These are errors in the code that somebody has written. They're not user error. They're not a problem that your end users are creating by invalid input. These are problems that are directly written into the code by the code writer. So examples are when a string is passed where an object was expected, probably by some type of function that's trying to use things in it that are in that object, trying to read a property that is undefined, calling an asynchronous function without a callback, and so on. We often use errors to mean both of these broad categories, but they're quite different. Operational errors are usually error conditions that all programs must deal with. They don't necessarily indicate a bug or a serious problem. By contrast, programmer errors are bugs. These need to be fixed. So that's the difference between operational and programmer errors. Now, next, what is event-driven programming? And Wikipedia has a basic explanation of this, and it says in computer programming, event-driven programming is a programming paradigm in which the flow of the program is determined by events such as user actions, mouse clicks, key presses, sensor outputs, or message passing from other programs or threads. And I like the great example of Kahoot. Now, somebody can come in here and they can use this application and they can create a really big or a really fun question and answer like query game, but it is entirely waiting on the user's input before it can do anything. And so somebody has to come in here and click play and click that button or that tag up there. Then they have to come in here and they have to enter into the game pin that they've gotten. Then they have to click enter. And then if they want to get a better score, they have to get the right answers that they input. And it's not until the game is started that a function runs that has the time that all of the entire game will be running on. And so that's a very, I think that's a good example. Another good example is somebody using their cell phone. They get to their home screen and it doesn't automatically open up the thing that they're thinking of. They have to go and find it and click it, and then they have to click into the home menu, or then they have to click into the details or profile information or email messages and then click respond, and it's all event driven. So that's what that event driven is. That's what that programming is. It waits for those either user inputs or waits for the responses back when it runs different things, and then it runs the next step. So what are worker processes is the next question. This is a little bit more difficult one, I think, because it says that worker processes are responsibility, but then it's with IIS, and I had to look up what is IIS, and that's Internet Information Services. Internet Information Services is a flexible general-purpose web server from Microsoft that runs on Windows systems to serve requested HTML pages, and it uses the Hypertext Transfer Protocol, HTTP. Now, worker processes in that, looked in here, and worker processes are basically like for Node.js, they're how many things are running at the same time, requesting either different pages or requesting different things to run on that CPU. And so there's multiple threads that can run in Node.js at the same time, so simultaneously or concurrently. And so those are those different worker processes. They're things that are running at the same time in Node.js. And I think if you think of like in your terminal, your node or your terminal is running not only one thing, but another thing and trying to fetch another thing or trying to work on another function or something like that. I think those are an example of node worker processes. Next is describe how Node.js can be made more scalable. And there's a blog post here. This is by Hiren Dudak. And he says, just gives an example. And so these are statistics of 51.4% developers regard Node.js as the most used tool earlier in 2020. But there are use cases of Node.js where it's talking about NASA, Twitter, Netflix, Trello, and it says Netflix decreased startup times and significantly improved performance. They migrated their backend from Java to Node.js that resulted in a decrease in startup time from 40 minutes to 60 seconds. And that's an impressive reduction in time. And so how is it scalable, though, is kind of the more pertinent question. And it says, by a simple search of this, scaling your Node.js is with a load balancer or across multiple machines. And I think this is more applicable not really by one person individually running the Node software on their personal computer, but when it gets uploaded into a server, such as Amazon Web Services or Google Cloud Services. And so they might have automatic scaling as an option, or like DigitalOcean. I think that's one of their advertisements, even, that it's automatically scalable, that you don't have to do anything. But if a increased amount of people all want to access your application at the same time, they'll expand how many servers are going to be running your application to meet that demand. And so automatically scaling that up. And Node.js performs well when automatically being scaled up with more machines running it at the same time. Explain global installation of dependencies. This is when a npm package, for example, is installed onto your machine, but it's not installed just in one like root directory down in like JS411 week 1 and then one of the applications, but it might be installed to the entire machine in a file that every different application, every different folder can access. And that'll be with the like -g flag. And so if we type in here like npm install, and then say we're trying to install Axios, but then we give it a global flag, and that might be passed right before the file name that's going to be installed. So npmi like -g global to install it globally. Now, normally you don't want to do this for things that are only going to be used just inside your one application, but this would be something that you want to use all over your computer in all of your different files. So that's the difference between global installation. Now explain RESTful web services. MDN describes this and defines it as representational state transfer. That's RE, representational, and then the S, state, and then T, transfer, and it refers to a group of software architecture design constraints that bring about efficient, reliable, and scalable distributed systems. So this is a design framework of how things are built, and specifically a lot of times refers to the way servers and APIs are built. And a great example could be if we're going to try to look up the random user.me, I put in this and it returns one user and it has his different information in there. Now, the other parts of this are like, the first part is the GET request type of part of it. I don't see that listed on here, but one is the GET request. Another is being able to post, which means to create something for the very first time in that database. And so a post request would be sent from the user through the server to the database, and that would be created in the database. A GET request would pull something through the server from the database. A put request, this would be an update request. All right, sorry about that. My headset just died, and the microphone that was included with it. So a put, an update, that would be an update request of that same information that goes through the server to the database and updates something that's already on the database. And then a delete request would go through the server to the database, and it would ask to the database to delete something that's already in there. So it would be removed. And so that type of design framework that is RESTful, when they adhere to these constraints, it's language agnostic. It seems to always work in those types of state transfers or state adjustments. It asks to get some of that state from the database. It asks to create some of that state in the database. It asks to update some of that state in the database, or it asks to delete some of that state that's in the database and remove it from there. Those are the framework or design constraints for RESTful web services. So those are the 6 different questions that we answered today. I hope these have been helpful to you. I hope that I've given some good examples. If you have any questions, please leave them below. I hope you have a great day, and that this has been a blessing to your code development. Good luck in your coding career.